The SSI MANTRA, designed and developed by SS Innovations, aims to provide a cost-effective, technologically advanced surgical robotic system to benefit many more patients around the world. SS Innovations is improving lives through innovation and care by bringing minimally invasive robotic surgery to the vastly underserved population of the world by decentralizing access and excellence. The Surgeon Command Center of the SSI MANTRA surgical robotic system allows the surgeon to remotely control the SSI mudra, endosurgical instruments, and endoscope via the surgeon hand control device. This can be observed on the high-definition 3D monitor with 3D glasses to enhance depth perception of the surgical field. A head-tracking camera unit on the monitor adds to the safety of the operation. With a retractable foot pedal tray, the surgeon has an array of controls, including robotic arm toggle, clutch function, camera control function, cut cautery function, and coagulate cautery function. A 2D touch monitor is given for additional system controls, and as a viewer, for live operative simulation, DICOM images, hemodynamics, and other important patient-related data. The ergonomics of the Surgeon Command Center is designed to allow the surgeon a complete view of the workspace, including the 3D monitor, the hand control device, and the foot pedals. All adjustable, with a touch of a button, on the front control panel. The patient-side arm cart of the SSI MANTRA surgical robotic system is a modular system component that works in units of 3, 4, or 5 independent robotic arms, depending on the surgical procedure. The patient-side arm cart can be differentiated into the cart, the mast, the setup joints or boom, the linear telescoping joint, the robotic arm, further segmented into the tool interface, the instrument actuator, and the instrument. The cart can be driven by patient-side assistance, using the throttle control in the back of the cart, for easy positioning and stowing. The control panel on the cart helps control the drivability and parking functions. Turn the patient-side arm cart on or off, using the Start-Stop button. To activate drive mode, make sure the Move button is pressed. Press the clutch button to engage mobility. This is indicated by the green arrow on the throttle display. Use the throttle to drive forward. To apply brakes, press the brake toggle switch on the left throttle. To drive the cart in reverse, press the reverse control button and use the throttle to drive backwards. This is indicated by the red arrow on the throttle display. The cart battery charge is indicated by the segmented lights adjacent to the arrows. Use the speed dial to set the cart into slow or fast driving speed modes. Press the lock button to park the cart for operational use. The boom control switch can be used to lower or raise the mast of the cart. And the input button is used to toggle the cart registration dial, a feature to locate the other adjacent patient-side arm carts, for simulation and collision detection. To set up the robotic arms of the cart for docking, and other pre-operative functions, clutch buttons are provided. The primary arm clutch button, on the side of the robotic arm, disengages the brakes of the setup joints, allowing the surgical staff to easily maneuver the arm for docking. The secondary arm clutch button, on the distal end of the tool interface, can also be used to free up setup joints and the linear telescoping joint for additional maneuverability. The instrument clutch button on the proximal end of the tool interface is used to engage the arm within the remote center of motion. After the joints have been set up and port placement completed, instruments can be loaded on the instrument actuator and inserted into the patient body cavity. The Vision Cart of the SSI MANTRA surgical robotic system is a visualization system component for the surgical assistants and staff. It bridges the gap between the surgeon and the assistants for a highly responsive workflow and quality clinical outcomes. The Vision Cart accommodates a variety of submodules. A large 3D HD monitor for a seamless visual interpretation of the surgical field. The Omni 3D HD video processing system, with a 2D touch monitor in the back of the Vision Cart, for recording, streaming, and playback functions and control. Speakers are provided for audible system messages, notifications, and warnings. Provision for an electrosurgical unit for cautery applications. An endoscope control module, with an articulating 3D endoscope, that can rotate 100 degrees in any direction within the body cavity with automatic focusing. A storage unit for instrument and cable management. A system control box for integrated robotic arm control and data management. A UPS module for uninterrupted power supply. And a CO2 cylinder bay.